Hello my dear students, good afternoon. Today we will discuss about preparations of aldehydes and ketones. Actually, first one is from alkenes. From what? Alkenes we will discuss, and that is also called ozonolysis. This you know already. In first year itself, ozonolysis of alkene you have, okay, that only we will discuss here, okay, but maybe long back you learn, so no problem, we will discuss now. So alkene on ozonolysis, what happens? So CH2 double bond CH2, when you are using O3, what happens? First, cyclic ozonide will form. So during cyclic ozonide, what happens? These two bonds will break. These two bonds means this double bond will completely disappear between these two carbons. So there, what you have, simply CH2 and CH2 you have, and three oxygens will form cyclic ozonide like this. What is this? Cyclic ozonide actually. Okay, now in presence of zinc, what happens? See this everyone. So one of the bond will break actually. So this bond is coming over here and this bond will come over here, and this oxygen absorbed by zinc, one of the oxygen. Okay, so what happens here? CH2O, one compound, so CH2 double bond O, because one of the bond migrated over here, no? So CH2 double bond O plus, and this bond migrated over here, no? So between carbon and oxygen, double bond, that is CH2 double bond O. So formaldehyde 2 moles you have, and along with that zinc oxide you have. What is this CH2O is called? CH2O. You can call it as HC double bond OH. Simply CH2O. So formaldehyde you have in this way. It's very simple. So when you have alkene in question, so CH2 double bond CH2, when O3 given like this in presence of zinc, and no need of writing all these things, only for PU exam you have to write like this. Otherwise, if this kind of question asked in NEET exam like that, okay, simple way, break it completely. Put one oxygen here and one oxygen here. One oxygen with total 3 oxygens, no? One oxygen with zinc. That forget. So simply break the double bond, put one oxygen here, one oxygen here. So our answer is CH2O, CH2O. That's it. So our products are 2 moles of CH2O. That's it. Okay. So if you have a question like this, CH3 and CH and double bond CH2, when zinc given like this. Now just break it again and put one oxygen here and one oxygen here. That's it. Now it's a very simple way, or not? Tell me. Completely breaking this double bond, that will disappear. So 2 moles of aldehydes, but different. Why? Here 2 carbons, here 1 carbon only you have. So with 2 carbons, 1 aldehyde you are having, that is CH3 CH double bond O. CH3CHO, and another is formaldehyde, that is CH2O, like this. Okay, so to get aldehydes and ketones, one question on ozonolysis, this year NEET exam you have. Okay, so which of the following will give some stone like that kind of question given. Okay, so what is ozonolysis product, or to get these kind of aldehydes, what is the alkene required, like that. Reverse also they will ask. To get acetaldehyde and formaldehyde, what is the alkene required, that also question. So ozonolysis is very, very important. So propene, so you have 2 aldehydes like that. Understood? So write down all this. Actually this is the process of ozonolysis, and this bond will migrate, double bond O, this bond will migrate, double bond O, and one of the oxygen combined with zinc. but actually this is the way to have a product easily. Okay, so simply I'll give you one more now. So I'll give here CH3 and CH2, C double bond O H and CH double bond O and CH2 and here CH3 and here CH2 CH3. To have these, okay, to have these products, what is the alkene required, they will ask. Okay, so when they ask like this, so they'll give products like this: CH3 CH2 CHO and CHO CH CH3 CH2 CH3. To have these two types of aldehydes, what is the alkene required? If they ask, what you have to do is combine these two carbons in which you have double bond O and double bond O. Understanding? So now remove these two oxygens and combine these with a double bond. Got it clearly? Now what will be the product? Remove those two oxygens and between these two carbons put a double bond now, so that you will get alkene. What is that alkene required? CH3 CH2 and CH, this carbon, this star carbon CH. Understood? Now and I am putting double bond here and again this CH, okay, and this star carbon. Both carbons I was combined and I got here, sorry, I have here like CH and CH3 and CH2 CH3. This is the alkene required. Correct or not? CH3 CH2 CH CH3 and CH double bond CH CH2 CH3. That's it. Got it? This is the alkene required to get these kind of products. Hope you understood. So what alkene required also they will give you. Suppose if you want ketone, which will give ketone like that, they'll ask you. CH3C and CH3 double bond CH CH3 on ozonolysis in presence of zinc, what you will have. Okay, very simple. Break double bond completely, put one oxygen here and one oxygen here. Very simple thing I'll tell you. If the double bonded carbon has a branch, pakka you will get ketone. Double bonded carbon don't have any branch. Suppose CH3 CH double bond CH and CH2 CH3. This is on ozonolysis in presence of zinc. What is the product? You know this already, but we are revising like that. Now what is the difference between this alkene and this alkene? This double bonded carbon, you have a methyl group as a branch, but come to this, you don't have any branch. Simply natural a normal chain it is 1 2 3 4 5, and especially these double bonded carbons, you don't have any branch, then pakka aldehyde will form. Very simple, sir. If double bonded carbon has no hydrogen, ketone. If double bonded carbon has hydrogen, aldehyde. That's it. On ozonolysis. Very simple or not? So you are putting two oxygens here. Now here also you will break and put one oxygen here and one oxygen here. Then you will get two types of products or not here? Tell me. So here what are the products? Here CH3, CH3, C and CH3 and double bond O, one product. CH3, CO, CH3, one product. And another is CH3, CHO, because this double bond carbon has hydrogen, so aldehyde. So you have CH and double bond O and CH3. Understood? So CH3, CHO. By giving this propanone and acetaldehyde, this is propanone or acetone, acetaldehyde, to prepare what type of alkene is required for ozonolysis. That is the question. Simple. Okay, propanone, this one, and now remove these two oxygens, then this alkene will come or not? CH3, CCH3, double bond, CH3, alkene you are having. Understanding? One more oxygen gone with zinc. Understood? Now here, what are the products in this reaction? CH3, CHO and CH3, CH2, CHO. Got it? So here the product is CH3 and CH double bond O plus. Broken now here, so they are plus. CH3, CHO and with 3 carbons one more. That is CH double bond O and CH2 and CH3 here. Excuse me. CH3, CHO one product, CH3, CHO one product, so CH3, CH2, CHO is another product. Over now. Understanding everyone? So this is one of the preparation from alkene. So if they want alkene, reverse, put these, remove these double bonded oxygens and put double bond between these two. That's it. So this is very simple preparation of aldehydes or ketones from what? From alkenes. If they given cyclic, then also you can get. Suppose if they given this double bond. Now on ozonolysis, O3 given in presence of zinc, what is the product if they ask? Then also you can say. Very simple way. So cyclopentene on ozonolysis, what is the product if they ask? Then also you can say. But these kind of cyclic compounds you will get only one product. Cycloalkenes, cycloalkynes, if they given, you will get only one product. But open chain means 2 products you are breaking completely and 2 products you are having. Suppose this one given CH3, CH and CH, suppose given this one and CH3, and here you have a double bond and here also you have CH3 and CH3 given on ozonolysis means what you are doing and breaking this, put one oxygen here and one oxygen here. Over now. CH3, C double bond to CH3, CH3, C double bond to CH3, that's it. 2 ketones you are having because there is no link between this carbon and this carbon. Last carbons are terminal carbons here. But here there is no terminal carbons, continuous compounds. So one product you will have. Are you thinking I am wasting time? No, actually. So I am giving the difference between open chain alkene and cyclic alkene. Now, very simple. Break this double bond. Same story. Put one oxygen here and one oxygen here. All ozonolysis, 2 bonds only will break. So wherever the double bond is there, that will break. That's it. Now, with how many carbons? 1, 2, 3, 4, 5 actually. So here you have like this. 1, 2, 3, 4 I written. 4 I written. So 1, 2, 3. Here see. 1, 2, 3. Those I have. 1, 2 and 3. So I am giving like that. 1, 2, 3. I will give here 1, 2, 3 to avoid confusion. So total 5 carbons actually. 1, 2, 3, 4. Numbering is wrong actually. 1, 2, 3 like that. Otherwise proper numbering I will give. 1, 2, 3, 4, 5. So here also I will give the numbering like that. So here you have 1. Yeah. 1, 2, 3, 4 and 5 now. So at first carbon 1 oxygen, that means you are having double bond OH and here also double bond O and H. Understood what happened here? So here CHO and here CHO. That means you can write like this otherwise. C double bond OH and here this CH2. This is what here? CH2 and here you have CH2 and here you have CH2 and C double bond OH. This one and this one both are same or not? See from this. See, I will give numbering now. 1, 2, 3, 4 and 5. Okay. or else you can give like this also, double bond O and double bond O, like this, all three are same. Understood? Cyclopentene, you don't have any branch of double bonded carbons, so two aldehyde groups. Got it? Now here means you know already product. CH3CO CH3, CH3CO CH3. 2 moles of acetone you have actually. So difference you understood? Suppose if I taken this example, now I have a methyl. So now very simple. You have 1, 2, 3, 4 and 5 on ozonolysis in presence of zinc. Sir, minus Z and O common. Zinc oxide will go. Now also same story actually. 1, 2, 3, 4 and 5. And here one branch also there. So now again I'll do the same. So this will break and I'll put one oxygen here and one oxygen here. That's it. With fifth carbon, one oxygen. This is fifth carbon, one oxygen. At first carbon, one oxygen. So what you have here, ketone I have double bond O and double bond O, but here H. So what is the difference between this and this? At first carbon you have ketone here. You observe CH3, C double bond O, CH2, 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 CH2 and CHO. If both has like this double bond and 2 you have alkyl groups on ozonolysis in presence of zinc, what is the product you can say now? Now definitely double bond will break and here one oxygen and here one oxygen. 2 oxygens you are having. Got it clearly? So here what happens? Here, see this, I am writing again. Here you have double bond and here you have 2 alkyl groups and you added O3. What is the product? So double bond you break, put one oxygen here, one oxygen here. Ketone you are having or not? Diketone. That means here the product is like this. So here double bond O and here also double bond O. Diketone you are having. Okay. So next, ozonolysis of alkynes we have to discuss. Next, ozonolysis of alkynes. Okay. So alkenes means what you are doing. Suppose I am just repeating CH3CH double bond CH, and here if you have CH3 on ozonolysis in presence of zinc, what you are doing? You are breaking completely 2 bonds and putting one oxygen here and one oxygen here, right? And your products are like CH3CH double bond O. 2 products you are having, CH3CHO and plus CH double bond O, CH3 you are having, right? Same way I was given this CH2 double bond CH2 when react with O3 in presence of zinc. So as I was given, double bond will break, one oxygen here, one oxygen here. So you are having CH2 double bond O plus CH2 double bond O you are having, along with that Z and O you are having. Am I given this? Why I am comparing? So that you can understand easily. Now CH triple bond CH when I am taking, this is alkene, ethylene. Now acetylene I am taking. Difference understanding? What this is? This is alkene. Here is what? Alkyne I am taking. When I am taking alkyne, what happens for ozonolysis? In presence of zinc. Same story, but in triple bond, 2 bonds will break. Means 2 pi bonds are there in triple bond. So those 2 bonds will break, 1 bond remains. So one product only will come. Understanding? This alkene giving 2 different, 2 aldehydes, 2 moles. But here 1 mole of product only you will have. Because in triple bond, 1 bond remains in product. That is like this, CH and single bond CH. So double bond you break and remains 1 bond. CH is there, CH is there. 1 bond remains among triple bond and put 1 oxygen here and 1 oxygen here. So what you have? CH double bond O, CH double bond O. Glyoxal or glycol. Okay, so what is this? Glyoxal or glycol. Understood clearly? So what happens if you use triple bond? Then CHO, CHO you have. Single bond remains there. Understood? So this is one of the important reaction. This is from what? Ozonolysis. What is that? Ozonolysis. Very simple. So one more I will give you here. So you tell me the products in our WhatsApp group. Pakka everyone must send. CH3, CH3 and sorry, and here no methyl. Yeah, CH3C, triple bond C, CH3. This is on reaction with O3. What happens? In presence of zinc. And this also give product. Triple bond you have, and when treated with O3, what happens with zinc? Got it? So boys and girls both have to give products for this. Okay? And now I will give CH3C, CH3, and here C triple bond C and CH3 like this. When react with O3, what is the product in presence of zinc? You have to say. So 3 reactions you have to complete. If you are unable to complete, I will give. What to do? I was given already. Double bond have to break and put one oxygen here, one oxygen here. Double bond here also you break and one oxygen here, one oxygen here. Double bond you break here, one oxygen here, one oxygen here. So you give what? Alkene, alkyne. So from alkynes you have to give products. So here no ketones, only you won't get aldehydes, sorry. You will get ketones only like that. Aldehyde when you get like CH3, C, triple bond CH if you have, when react with O3, now you will get, this is aldehyde group and this is ketone. Here what is the product? CH3, double bond you have to break or not? Double bond you have to break. CH3C and double bond O and CH double bond O. Understanding? So CH3, C double bond O. Why are you different? Understood? C double bond O, double bond you broken. So this is another reaction. C double bond O and CHO. If triple bond in middle, you have ketones only. Keto groups, diketo. Here also double bond will break. One bond remains. So what is the product here? Understood? 2 bonds you have to break and put one oxygen here and one oxygen here. So you give me the 3 products please, everyone. Understood? So this is ozonolysis of alkynes. Alkynes on ozonolysis. If triple bond in middle, diones you will have. If triple bond at terminal like this, and the last one has aldehyde and the middle one has ketone like this. So these are very, very important. Now third one I will give you from alkynes only, from alkynes, but by hydrolysis, acid hydrolysis. Here only tautomerism is very important. We use that. Okay. Suppose CH triple bond CH on treating with water. Hydrolysis means that only 40% H2SO4 and 4% HgSO4. Very simple and important. 40% like that also they will give on arrow. 40% H plus and 4% Hg plus, like this also they will give on arrow. But simple, addition of water by Markovnikov rule. Addition of water by Markovnikov rule. So that means water means what here? OH minus and H plus. So if this migrate over here, because both carbons are similar, so any direction you can migrate one of the pi bond. So this one of the pi bond if migrate over here, this carbon gets negative charge and this carbon gets positive charge. Correct? So OH minus will add on this positive carbon and H plus will add on this. Following everyone, this H plus will add on this because this will be negative. Okay, so H plus will add and this positive carbon on that OH minus will add. So certainly here what happens? CH2 and CHOH. Is it called enol? Because triple bond become double bond and H plus was added here. If you want, I will write clearly one of the hydrogen was added here and OH was added here, water molecule. So this is called, what this is called? Tautomerism. Do you remember tautomerism? Why important? So this is enol form and this will migrate over here and this will come back here so that your product is CH3 single bond CH double bond O, aldehyde you are having. Got it? This is alkyne with water, addition of water in presence of 40% H2SO4 and 4% HSO4. You are having Mr. Who is this? Enol form, and on tautomerism it converts to aldehyde. Got it? So this is the way to get Mr. aldehyde. If you want ketone, suppose, then CH3, you won't get formaldehyde from this. Minimum 2 carbons, acetaldehyde. Okay? Because in alkenes or alkynes, minimum how many carbons there? 2 carbons. But formaldehyde, 1 carbon. Like that they'll ask question, which of the following process is not suitable to prepare formaldehyde? This is not suitable to prepare formaldehyde. That's why I am saying, not for time wasting. Triple bond CH. CH3C triple bond CH. Propyne. Same story. Here given water plus H2O. Okay. Here same story. 40% H plus and 4% Hg plus given means addition of water. This also they won't give water, just for convenience I am giving. 40% means water is there. Water also they won't give. Propyne, water they won't give actually. So they will give 40% H plus and 4% Hg plus. What is the product they'll ask you. Okay. Now what is the product here for this reaction? This product is belongs to this. Okay. Propyne given, water not given, then also addition of water. So H plus and OH minus addition takes place. That must strike in your brain. So for this propyne, when I am adding this water, according to Markovnikov rule means, do you remember? Negative species will add to the unsaturated carbon which have less number of hydrogens. Do you remember? I said many times, the pi bond always migrate from the carbon which have less number of hydrogens. I told. So this pi bond will migrate over here. So positive charge here means secondary carbocation is more stable than primary, right? This will be primary, this will be secondary. Tertiary possible, tertiary. 1 to migrate, 1 to hydride shift, 1 to methyl shift, like that also I said. First complete this reaction, sir. Why you are saying all those things, sir? Thinking like that? No. We have to recap all the things. So here what happens? Addition of water. So same story. This carbon gets positive. So OH minus. So Markovnikov rule, do you remember? Negative species will add to the unsaturated carbon which have less number of hydrogens. So this carbon has less, or this carbon gets positive. Why positive charge understood? Pi electrons migrated. Yeah. So now the product is like this, CH3 and C and here OH and double bond CH2. Double bond CH2 you have here in between. So this is the enol form. Enol form further converts to, this is what form? Enol form, and further converts to keto form. So propyne on this, you are having ketone or not? So this is actually CH2. So now on tautomerism, you are having this CH3, C double bond O and CH3 like this. Ketone you are having on top of this enol form, and this is keto form. So propine on treating with 40% H2SO4, 4% HgSO4, you are getting propanol, not aldehyde, because you are using here H2SO4 and HgSO4. Sir, propanaldehyde can be prepared, then anti-Markovnikov rule we have to use. Anti-Markovnikov rule means, do you remember, we have to use peroxide here. Along with this, if you use peroxide, then OH minus will add at first carbon. Certainly your product is aldehyde. Got it clearly? So these are very important. Here no peroxide. So propanol, negative species added to this unsaturated carbon, triple bonded carbon, which have less number of hydrogens. Got it? So this is about hydrolysis of Mr. Alkynes. Okay, write it now everyone. So here actually propine I written. Have a screenshot please everyone. Okay, so write down. Notes is very important. So you have to revise all these things. We will discuss, but we can recap all these things once offline classes started. Definitely you will get revision. Pakka, I am sure. Okay. Because after this, in organic, only two chapters remains. One is carboxylic acids and one is organic compounds containing nitrogen. That's it. In organic chemistry, very simple. And they are also saying 30% syllabus from inorganic itself they will remove. Certainly, we physical almost completed. Okay, except surface chemistry. And here, this is the third chapter. Two more are there. That's it. Pakka they will remove some syllabus actually. So you have no need to worry, but you have to write notes properly. We will revise also, but you need to practice more. Okay, so hydrolysis reaction only I will give now, and the fourth one, third one itself. But according to anti-Markovnikov rule, how product will form, I will tell you now. See this given like this, and 40% H2SO4 given, and 4% HgSO4 given, and along with that hydrogen peroxide like that given. Simply not only this. So better to write peroxide. If other peroxide if given, you feel sir H2O2 not given, no sir I forgot, you will say. Peroxide like H2O2 or benzoyl peroxide. If they given, then you know what is the product? In addition of water, H plus and OH minus. This OH minus will add on the unsaturated carbon, which has more number of hydrogens. Certainly you are having CH3 and CH and double bond CH2OH. What happened here understood? This OH minus added because migration is same, but here migration is different actually. OH minus will come over here because peroxide used. Now on tautomerism, understanding according to peroxide means according to anti-Markovnikov rule. So on tautomerism, here you have a product. This will come back like that. That means the product is here CH3 and CH2 and CH. Oh my God, here CH2I and CH double bond O. CH3, CH2 and CH double bond O aldehyde you have if you use peroxide. Okay, and fourth one is from gem-dihalides, not vicinal. Gem-dihalides. Wow. Today I am not writing properly, correct? From gem-dihalides. So very important, sir. Gem-dihalides means, do you remember? RCX and X, two halogens attached to same carbon. So this or else RCH and X and X. Why I written 2, not mad fellow? This is on treating with aqueous KOH2 moles ketone. and this on treating with aqueous KOH, then you are having aldehyde. But how many moles we have to take? 2 moles we have to take. 2 moles of aqueous KOH ketone. What's the difference? Very simple. Here middle carbon, any one of the middle carbon has 2 halogens, but here terminal carbon has 2 halogens. If terminal carbon has 2 halogens, then you are having aldehyde on hydrolysis. Understanding, sir? So very important. I will write only one reaction, but remaining we will continue later. CH3, CHCl and Cl. When you are using 2 moles of aqueous KOH, what is the product, can you say? So our product is CH3 aqueous KOH. Do you remember alkaline KOH and aqueous KOH? So Cl replaced by OH. So CH3 and CH and OH you have. What I did understood? This is gem-dichloride, geminal dichloride, or 1,1 dichloroethane, 1,1 dichloroethane, 2 moles of aqueous KOH, then you are getting diol. So by removing water molecule, do you remember if carbon has 2 OH groups, in Raymer-Tamer reaction also I was given same manner, 2 OH groups at 1 carbon, water will go, correct? Water will go there, so minus H2O, and here the product is CH3, CH, double bond O, aldehyde is the product. Same, if you take this one, you write down the product CH3 and Cl here and Cl here and Cl here. When you take aqueous KOH, what is the product? Again you send product to me in our WhatsApp group. Just I was given the ozonolysis, along with that this also you have to send. Alright sir, thank you very much. And this you finish with aqueous KOH 2 moles, and here I was given you have aldehyde here, and here you will get ketone. Actually, why you will get ketone here? Because this middle carbon has 2 chlorines. So 2 OH groups will come at middle carbon, water will be removed, and CH3 C double bond O CH3. We only said product here. So you finish this reaction and you finish the previous reactions of ozonolysis, and you send and prepare all these, and these are very important. Thank you.